In a stunning revelation that has sent ripples through the scientific community, renowned astrophysicist Avi Loeb has made a bold claim. The mysterious interstellar object 3I/Atlas is not just passing through our solar system, it is here to stay. For weeks, astronomers have been watching this enigmatic object as it travelled through our cosmic neighbourhood at a speed that defies conventional understanding. But Loeb, with his trademark confidence, believes that this is no mere visitor. He argues that 3I/Atlas has been captured by the Sun's gravity and will remain within our solar system for much longer than anyone anticipated. This assertion has sparked a firestorm of debate among scientists, with many questioning the object's origin, its trajectory, and the implications for our understanding of interstellar travel. 3I/Atlas, which was first detected by the Pan-STARRS telescope in 2017, was initially thought to be a fleeting passerby, a comet from another star system that was simply passing through on its way out. However, Loeb's claim suggests otherwise, raising the possibility that 3I/Atlas might be the first of many interstellar objects to be permanently captured by our Sun. The object's unusual speed and trajectory have puzzled astronomers since its discovery. It was moving faster than any object from within our solar system, and its path did not fit with the expected trajectories of typical comets or asteroids. Some scientists suggested that 3I/Atlas might be a fragment of a larger body, or even a piece of alien technology, but no one could agree on what it was, or where it came from. Loeb's theory challenges many of these assumptions. If 3I/Atlas has indeed been captured by the Sun's gravity, it opens up an entirely new chapter in our understanding of interstellar objects. Could this be the first real evidence of an object from another star system making its home in our cosmic backyard? Or is this just the beginning of a new wave of interstellar visitors? What's more, the implications of Loeb's theory go far beyond the realm of astronomy. If 3I/Atlas is truly here to stay, it could mark the beginning of a new era in space exploration. For decades, scientists have speculated about the possibility of interstellar travel, but the idea of an object from another star system being permanently captured by our Sun could offer invaluable insights into how objects from other stars interact with our solar system. As we move forward, one question remains. Is 3I/Atlas simply an anomaly, or is it a harbinger of more interstellar objects to come? The answer could reshape the way we think about space, our solar system, and even the potential for life beyond Earth. The next few years will be crucial. Stay tuned as we dive deeper into the mysteries of 3I/Atlas and explore what this discovery means for the future of space exploration. When 3I/Atlas was first discovered in 2017, astronomers initially believed they were observing a typical interstellar object, a comet or asteroid passing through the solar system on its way out. It was a fleeting visitor from another star system, a cosmic wanderer whose journey would continue far beyond the reach of our Sun. However, as researchers tracked its trajectory and observed its behaviour, they noticed something unusual. 3I/Atlas was not acting like other objects in the solar system. Unlike typical comets, which brighten as they approach the Sun due to the sublimation of ice, 3I/Atlas exhibited an unpredictable and rapid brightening pattern. It grew brighter at an unprecedented rate, much faster than any known comet. This sudden and dramatic increase in brightness suggested something extraordinary was happening. But what could it be? Astronomers initially hypothesized that the object might be a fragment of a larger body, perhaps shattered by a recent collision. This could explain the rapid brightening, as smaller fragments of an object would release energy more quickly when exposed to sunlight. However, Harvard astrophysicist Avi Loeb offered a different theory. He proposed that the brightening wasn't a result of a collision, but was due to the unique properties of 3I/Atlas itself. According to Loeb, the object's rapid brightening could be caused by highly reflective materials on its surface, which are not typical of most interstellar objects. Loeb further speculated that these materials could be artificial, remnants of technology that survived its passage through space. Loeb's theory builds on his broader view of interstellar objects. Having previously raised similar questions about the interstellar object Oumuamua, Loeb suggested that such objects could be artificial probes or fragments of advanced technology from distant civilizations. If 3I/Atlas is indeed an artificial object, it could be the first concrete evidence of extraterrestrial life beyond Earth. This would be a groundbreaking discovery, potentially shifting the entire focus of the search for intelligent life in the universe. The mystery surrounding the brightening, combined with the object's unusual trajectory, has made 3I/Atlas a subject of intense scientific scrutiny. While some scientists remain cautious about jumping to conclusions, the possibility that 3I/Atlas could be artificial is compelling enough to warrant further investigation. Loeb's argument rests on the improbability of such an object existing naturally in our solar system, prompting a rethinking of our assumptions about interstellar objects. One key aspect of the mystery is the object's rapid brightening, which scientists have struggled to explain with conventional models. It doesn't match typical behavior observed in comets or asteroids, leading to the hypothesis that it might be something entirely new, perhaps an artificial object, as Loeb suggests. Loeb's proposal challenges the conventional view of interstellar objects as natural phenomena. He argues that if 3I/Atlas is indeed artificial, it would offer a new way of thinking about objects that traverse the galaxy. This theory could also have profound implications for the way we search for extraterrestrial intelligence, suggesting that advanced civilizations might leave behind such objects as probes or even relics. The unusual nature of 3I/Atlas also raises larger questions about the nature of interstellar objects in general. If 3I/Atlas is artificial, it could signal that other objects entering the solar system may have similar origins, prompting a re-evaluation of how we classify and interpret these cosmic visitors. As technology advances, future interstellar objects could be studied with even more detail, potentially revealing more examples of artificial objects and expanding our understanding of the cosmos. For now, the mystery of 3I/Atlas remains unresolved, with scientists continuing to observe and analyze the object as it moves through the solar system. Its behavior is unlike anything seen before, and its origins, whether natural or artificial, are still up for debate. The debate surrounding 3I/Atlas has sparked widespread interest in the scientific community, with some scientists calling for more research to explore its potential as a signal from another civilization. Regardless of its true nature, 3I/Atlas is a reminder of the vastness and mystery of the universe. Whether it is a natural object, a fragment of a larger body, or a relic of an alien civilization, it challenges our understanding of the cosmos and pushes the boundaries of our knowledge. As Loeb suggests, its stay in the solar system might not be as brief as initially expected, and its future trajectory could provide new insights into the workings of the universe and the possibility of intelligent life beyond Earth. One of the most striking features of 3I/Atlas is its trajectory. As it entered our solar system, its path immediately raised questions among astronomers. Unlike typical objects, comets, asteroids and the like, that pass through the solar system, 3I/Atlas wasn't following the expected curved trajectory dictated by the Sun's gravitational pull. It appeared to be travelling too quickly to be captured by the Sun, suggesting that it would pass through and continue its journey into interstellar space. However, Avi Loeb, ever the iconoclast, proposed an alternative theory. Rather than simply passing through, 3I/Atlas might have been gravitationally captured by the Sun. The standard understanding of solar system dynamics predicted that an object travelling at the observed speeds of 3I/Atlas would not remain in our solar system. Its escape velocity was simply too high, yet 3I/Atlas did not follow the expected trajectory of a one-time pass. Instead, it appeared to slow down and change course, exactly as would be expected from an object captured by the Sun's gravity. Loeb's theory is based on the physics of gravitational capture, a process where the gravitational force of a larger body, such as a planet or star, slows down a smaller object, causing it to fall into orbit. This is more complex than a simple gravitational interaction and involves intricate forces specific to the object. Loeb's question is whether 3I/Atlas could be the first known interstellar object to undergo gravitational capture by the Sun. This notion challenges long-standing assumptions about the behavior of interstellar objects. Traditionally, scientists assumed that objects like 3I/Atlas would simply pass through our solar system and continue their interstellar journey. However, Loeb's perspective turns this assumption on its head. He argues that the Sun's gravity might not be so easily escaped, even by objects travelling at high speeds. Loeb suggests that the Sun's gravitational influence could allow for a subtle, long-term capture, a possibility that scientists hadn't fully considered for interstellar objects. This theory isn't merely theoretical, it has practical implications. If 3I/Atlas is indeed captured by the Sun, it would remain in our solar system for an extended period, providing astronomers with the unprecedented opportunity to study it in detail. For the first time, scientists could observe an object from another star system up close, potentially revealing new insights into the nature of the universe and the potential for life elsewhere. At the same time, Loeb's theory forces us to reconsider the dynamics of our solar system. If 3I/Atlas was captured by the Sun, could other objects, perhaps even larger ones, also find their way into the solar system in the future? How often might this happen? And how might this discovery influence the future of space exploration and our understanding of the vast interconnected universe? As 3I/Atlas continues its journey through our solar system, these questions remain central to scientific inquiry. While Loeb's theory is still far from universally accepted, the possibility that 3I/Atlas could have been captured by the Sun presents a tantalizing avenue for exploration. The object's unusual trajectory might be more than just a quirk of fate. It could signal a new way of thinking about how interstellar objects interact with our solar system. If Loeb's hypothesis is correct, the implications for future research could be profound. It would suggest that, contrary to our assumptions, interstellar objects might not only pass through our solar system, but could also be captured into orbit by the Sun. This would open up new possibilities for studying such objects in detail, potentially shedding light on their origins and the broader structure of the galaxy. It could also change our understanding of the dynamics of other star systems, raising the possibility that they too might capture interstellar objects in ways we hadn't previously imagined. In a broader sense, Loeb's theory could have implications for the search for extraterrestrial life. If interstellar objects like 3I/Atlas are not just random wanderers, but could be captured by gravitational forces, it might suggest that similar forces could be at play elsewhere in the galaxy, potentially allowing life or technology from distant star systems to make their way into our own. This would add a fascinating new dimension to the ongoing search for signs of extraterrestrial intelligence. Ultimately, the story of 3I/Atlas is far from over. Its unusual trajectory continues to spark debate and curiosity. Whether it turns out to be an artificial object, a fragment of a shattered comet, or a strange natural phenomenon, 3I/Atlas has already made its mark on our understanding of the cosmos. And as Loeb's theory suggests, its role in the solar system may just be the beginning of a more profound exploration into the forces that govern our universe and the objects that traverse it. Avi Loeb is no stranger to controversy. Throughout his career, he has consistently pushed the boundaries of accepted scientific thought, often challenging mainstream ideas about the universe. His claim that 3I/Atlas could stay in our solar system is just the latest in a series of audacious theories that have made him both a celebrated and polarizing figure in the scientific community. Loeb's reputation was cemented years earlier with his work on Oumuamua, another interstellar object that passed through our solar system in 2017. Loeb famously argued that Oumuamua might not be a natural object at all, but rather an artificial one, possibly a probe sent by an extraterrestrial civilization. This theory, while controversial, sparked widespread debate and led to increased scrutiny of interstellar objects. It also laid the groundwork for his current claim about 3I/Atlas. In Loeb's view, the mystery surrounding 3I/Atlas is not a simple case of an object passing through our solar system. Instead, he suggests that this object might be the first confirmed example of a permanent resident from another star system. Loeb's bold assertion that 3I/Atlas has been captured by the Sun's gravity challenges traditional theories of how interstellar objects behave and has opened up new lines of investigation. Loeb's arguments are not based purely on speculation, however. His theory is grounded in the physics of gravitational dynamics and the specific characteristics of 3I/Atlas. He points to the object's unusual speed, its trajectory, and its strange behaviour as key evidence that suggests it could be captured by the Sun. The object's trajectory, which appeared to defy expectations, is one of the primary reasons Loeb believes 3I/Atlas could have been permanently captured. Moreover, Loeb's theory is not confined to a single object. In fact, he has suggested that 3I/Atlas may be the first in a potential series of interstellar objects that could be drawn into the solar system. If the Sun's gravitational influence is strong enough to capture 3I/Atlas, could other objects from distant star systems also be caught in our solar system's gravitational pull? And if so, what might they tell us about the nature of the universe and the potential for intelligent life beyond Earth? In advocating for this theory, Loeb is not just questioning the trajectory of a single object. He is challenging the very foundations of how we understand the movement of interstellar objects within our solar system. His hypothesis offers a new perspective on the solar system's dynamics, one that takes into account the possibility of capturing interstellar objects. If his ideas are proven correct, it would represent a major shift in our understanding of space and our place within it. Yet, Loeb's theories are not without their detractors. Many in the scientific community remain skeptical of his claims, arguing that the evidence for 3/Atlas being captured by the Sun is far from conclusive. Some critics suggest that Loeb's theories are overly speculative and not grounded in the rigorous observational data needed to support such extraordinary claims. Others point out that while 3/Atlas's trajectory is unusual, it doesn't necessarily imply that it has been captured by the Sun. Despite this, Loeb's boldness in pursuing these ideas has pushed the conversation forward. Whether or not his theories about 3/Atlas will be ultimately validated, they have sparked a broader discussion about the nature of interstellar objects and their potential impact on our solar system. By introducing the possibility that objects from other star systems might not only pass through, but could be captured by our Sun, Loeb is opening up new frontiers for exploration and raising questions that could reshape the future of astrophysics. As the scientific community continues to study 3/Atlas and other interstellar objects, Loeb's theory will undoubtedly remain at the centre of the debate. His willingness to entertain ideas that others might consider fringe is a hallmark of his approach to science. And while his theories may be contentious, they also serve as a reminder of the ever-evolving nature of scientific inquiry, where even the most unconventional ideas can lead to groundbreaking discoveries. Loeb's work challenges scientists to think outside traditional boundaries, asking us to consider possibilities that may seem improbable at first glance. In doing so, he not only reshapes how we view interstellar objects, but also encourages us to continually reassess our understanding of the universe. And his theories, though controversial, highlight the importance of keeping an open mind in science, as new knowledge often emerges from unexpected directions. Whether or not 3/Atlas will eventually prove to be a captured interstellar object, or simply a passing visitor, Loeb's contributions to the field are undeniable, pushing us to reimagine what is possible in the search for answers about our cosmic neighbours. If Avi Loeb's theory that 3/Atlas has been captured by the Sun holds any truth, it demands that we reconsider many of the assumptions we've held about the nature of our solar system and its dynamics. The way we understand the solar system's gravitational interactions, the movement of interstellar objects, and even the future of space exploration could be fundamentally altered. For years, the standard narrative in astronomy has been that interstellar objects, like 3/Atlas, simply pass through our solar system. They are fleeting visitors, passing by the Sun and other celestial bodies, never staying long enough to interact meaningfully with our gravitational field. This assumption is grounded in the belief that the Sun's gravity, while strong, is not powerful enough to capture objects from outside our solar system permanently. Once an interstellar object passes through the solar system, it's expected to continue its journey into the vast expanse of space, never to return. However, if Loeb's claim is correct, this understanding of the solar system's dynamics could be seriously flawed. Gravitational capture, a process that is typically associated with much larger bodies like planets or moons, may be more common than we think. If the Sun can capture objects as small as 3/Atlas, then the likelihood of other interstellar objects being captured in the future becomes a very real possibility. This would fundamentally change our understanding of the solar system as a transient, ever-changing entity, and could reveal a more complex and dynamic system that is far more interconnected with the universe beyond. Moreover, the implications of this theory are not purely theoretical, they could have profound implications for space exploration. If the Sun has the power to capture objects from other star systems, it raises the question of whether we might one day be able to study these objects in detail. The current trajectory of space exploration focuses primarily on distant stars and planets within our solar system, but a captured interstellar object could offer a more direct and accessible way to study the physics of distant star systems and even the potential for life beyond Earth. Consider this: if 3/Atlas remains in our solar system for an extended period, it could become a target for future space missions. Its unique composition and origin would make it an invaluable subject for scientific study, offering insights into the nature of interstellar matter, the history of our solar system, and possibly even the origins of life itself. This could be the first time humanity is able to study an object from another star system up close, in a way that we simply cannot with distant exoplanets or other remote astronomical bodies. But the implications of Loeb's theory go beyond just the study of individual objects. If gravitational capture is a more common phenomenon than previously thought, we might start to see the solar system as a much more dynamic, ever-evolving entity. Objects from other stars may not just pass through, but could interact with the gravitational forces within our solar system, altering their orbits and trajectories in ways we have not yet anticipated. The dynamics of these interactions could be subtle, but they would likely affect how we think about the formation and evolution of solar systems, not just our own, but those around other stars, and this could expand our understanding of how life might travel between stars. The idea that objects from distant star systems could be captured by other solar systems opens up intriguing possibilities for panspermia. The theory that life, or the building blocks of life, could spread across the galaxy via interstellar objects. This new paradigm would force us to rethink our approach to space exploration, and even our understanding of how life might exist in the universe. If objects like 3I/Atlas can remain in our solar system, they could provide a bridge to explore the cosmos in ways that we have not yet imagined. Our solar system, long viewed as a relatively isolated corner of the universe, could turn out to be far more interconnected with the stars around us than we have ever realized. As we continue to study 3I/Atlas and other interstellar objects, we must remain open to the possibility that our solar system is not just a passive observer of the universe, but an active participant in the broader cosmic drama. And as Loeb's theory gains traction, the future of space exploration could be forever changed. One of the key reasons that 3I/Atlas has generated such intense interest among astronomers is its unusual speed. This interstellar object was moving through our solar system at a velocity much higher than any typical comet or asteroid from within the solar system. This raised a major question. How could something travelling this fast become gravitationally bound to the Sun? Typically, objects that enter the solar system from interstellar space move fast enough to escape the Sun's gravity, never to return. The reason is simple. The Sun's gravitational influence is not strong enough to slow down these objects to the point where they can become trapped in orbit. The vast majority of objects that come from outside our solar system pass through, continue on their way, and never interact with the Sun's gravity in a significant way. However, 3I/Atlas's speed defied these expectations. It entered the solar system at an unprecedented speed, much higher than typical comets and asteroids, yet it didn't simply pass through. Instead, its trajectory suggested it might be slowing down, a subtle but crucial shift that might indicate it was being captured by the Sun's gravity. This unusual speed is part of what makes 3I/Atlas such an intriguing object. Its velocity, which initially made it seem like an impossible candidate for capture, is one of the central pieces of evidence that Loeb points to in support of his theory. According to Loeb, the object's high velocity might actually play a critical role in its capture, not its escape. The physics of gravitational dynamics are more complex than they appear on the surface, and objects moving at high speeds can sometimes experience subtle interactions with gravitational fields that can alter their trajectories in unexpected ways. In Loeb's view, the unusual speed of 3I/Atlas could be indicative of a process known as gravitational slingshot, or gravity assist. This is a technique that spacecraft often use to gain speed and alter their trajectories by passing close to a planet or other large body. While this effect is most commonly used by human-made spacecraft, Loeb suggests that a similar interaction could be happening with 3I/Atlas, albeit on a much grander scale. As 3I/Atlas approached the Sun, it would have been influenced by the Sun's immense gravitational field. According to Loeb, this interaction may have resulted in a temporary deceleration that would allow the Sun's gravity to slowly capture the object despite its high velocity. This process would have been a subtle one, gradually altering the object's speed and trajectory, bringing it into the Sun's gravitational grasp over time. The idea of a high-speed object being captured by a star's gravity is not entirely unprecedented in theoretical physics. While most interstellar objects are expected to pass through our solar system, Loeb's suggestion that 3I/Atlas may be an exception is grounded in the complexities of gravitational mechanics. The velocity of 3I/Atlas, while high, may not be an obstacle to capture if the right conditions are met. In this context, Loeb's theory raises important questions about the nature of interstellar object interactions. If 3I/Atlas was indeed captured by the Sun, it would represent a significant departure from our current understanding of how interstellar objects behave when they encounter gravitational fields. It would suggest that high-speed objects may not necessarily escape our solar system. They could, under the right circumstances, be slowed down and captured. Additionally, if the capture of high-speed objects is possible, it opens up the possibility that other interstellar objects could follow a similar path. Objects that are travelling at seemingly impossible speeds could, in fact, be captured by the Sun, or even by the gravitational fields of other large bodies in the solar system. This could mean that the solar system is not merely a passive participant in the cosmic flow of interstellar objects, but an active player in the dynamics of the galaxy. The implications of this idea extend far beyond 3I/Atlas. If Loeb's theory is correct, it could lead to a paradigm shift in how we think about the movement of objects through space. It could suggest that objects that once seemed to be passing through our solar system, fleeting visitors, could in fact be potential long-term residents. When Avi Loeb first made waves in the scientific community with his theory about Oumuamua, a mysterious object that passed through our solar system in 2017, he ignited a heated debate about the nature of interstellar objects. Loeb's radical suggestion that Oumuamua might be an artificial probe or some form of alien technology seemed almost too far-fetched for many in the scientific community. Yet, his hypothesis was grounded in facts that, at the time, were difficult to explain using conventional models. Fast forward to the discovery of 3I/Atlas, and Loeb's approach to interstellar objects has gained renewed attention. His theory about 3I/Atlas is not entirely disconnected from his earlier work on Oumuamua. In fact, Loeb's ideas regarding the two objects are remarkably similar. Both exhibit unusual characteristics that defy simple classification, characteristics that, in Loeb's view, could point to an origin far more complex than any natural explanation. Oumuamua, as Loeb pointed out, was unlike any asteroid or comet that had been observed before. Its shape was irregular, it accelerated in a way that could not be fully explained by the gravitational pull of the Sun, and it exhibited strange fluctuations in brightness. These anomalies led Loeb to propose that Oumuamua could be a probe, an artifact created by an advanced extraterrestrial civilization, possibly sent to explore our solar system. Similarly, 3I/Atlas also exhibits characteristics that don't easily fit into the typical categories of interstellar objects. The rapid brightening, its unusual trajectory, and now Loeb's suggestion that it could be captured by the Sun all raise questions that challenge current astronomical models. Loeb's assertion that 3I/Atlas might be artificially created or be a fragment of a larger technological structure echoes his previous claims about Oumuamua. The connection between the two objects, however, goes beyond just the anomalies they share. The trajectory and speed of both objects raise fundamental questions about the way interstellar objects interact with our solar system. Both Oumuamua and 3I/Atlas have demonstrated behaviours that, at first glance, don't fit with what we would expect from naturally occurring asteroids or comets. In Loeb's mind, this points to the possibility that these objects were deliberately designed or modified, perhaps as probes or scouts from another civilization. While most of the scientific community remains cautious about attributing artificial origins to either Oumuamua or 3I/Atlas, Loeb's theories offer a provocative alternative. His view challenges the assumption that all interstellar objects must follow the same rules of natural physics that we observe in our own solar system. If Oumuamua and 3I/Atlas are indeed artificial, it would represent an entirely new understanding of how life and technology could potentially travel between stars. Moreover, Loeb's insistence on the artificial nature of such objects is not a case of grasping at straws. His theories are built on the understanding that the universe is vast, and our current models of how it functions are just scratching the surface. If we acknowledge that life may exist beyond Earth, then the possibility that extraterrestrial technology exists and could be represented by objects like Oumuamua and 3I/Atlas becomes more conceivable. What Loeb is asking us to consider is a paradigm shift. Rather than dismissing unusual objects, we should explore them as potential signs of something far beyond our current scientific comprehension. Of course, not everyone agrees with Loeb's theories, critics argue that the peculiarities of objects like Oumuamua and 3I/Atlas can be explained by natural phenomena, such as the release of gas from an active comet or the irregular shape of an asteroid tumbling through space. However, Loeb's stance challenges the scientific community to broaden its thinking and consider more extraordinary explanations. Could these objects be the result of forces and technologies that are far beyond anything we have imagined? In the case of 3I/Atlas, Loeb's hypothesis is even bolder. While Oumuamua was a brief visitor, 3I/Atlas might not be leaving our solar system anytime soon. This theory raises the stakes even higher. If 3I/Atlas is indeed captured by the Sun, could it represent the beginning of a new era of interaction with interstellar objects? And if these objects are artificial, what does that mean for the future of space exploration and the search for extraterrestrial life? For Loeb, the connection between Oumuamua and 3I/Atlas is not just a coincidence. It's a continuation of the questions he's been asking about the universe for years. If we are to expand our understanding of what is possible in the cosmos, we must be willing to entertain ideas that challenge conventional wisdom. And while Loeb's theories may be controversial, they are also pushing the boundaries of our knowledge, urging us to think outside the origin of 3I/Atlas has been the subject of much debate since its discovery. For a while, it was classified as just another interstellar object, another rogue asteroid or comet zipping through our solar system. But as astronomers continued to study it, the data began to paint a picture that was more complex and mysterious. What made 3I/Atlas truly unique was not just its unexpected trajectory and brightening, but the subtle clues that suggested it might not be a typical object at all. Avi Loeb, in particular, has put forth several bold hypotheses about the object's origins, many of which challenge our current understanding of cosmic phenomena. While it is still early to confirm any of these theories definitively, they have forced astronomers and astrophysicists to reconsider the possibilities of what 3I/Atlas could be. Could it be a fragment of a larger body, an object of natural origin that has been altered in some way? Or is it something entirely more extraordinary, perhaps even artificial? One theory that has gained attention is that 3I/Atlas could be a fragment from a shattered planet or moon, possibly a remnant of an ancient collision in its home star system. This idea is grounded in the behaviour of the object itself. As it passed through the solar system, 3I/Atlas exhibited unusual brightening, which some astronomers initially attributed to the release of gases from the object as it warmed up near the Sun, akin to a comet. However, the object's trajectory and rapid brightening suggested that it could be part of a larger object that was broken apart, releasing fragments into space. Loeb's own theory, however, extends beyond this natural explanation. He suggests that 3I/Atlas could be a manufactured object, or part of a technological probe sent by an extraterrestrial civilization. Loeb has long been a vocal advocate for the idea that interstellar objects may not simply be random natural phenomena, but could instead be engineered artifacts from advanced alien societies. This hypothesis, although highly speculative, finds some support in the data surrounding 3I/Atlas. Loeb points to the object's high reflectivity as a clue that it might not be naturally occurring. The rapid brightening that occurred as 3I/Atlas passed through our solar system could be indicative of highly reflective materials on its surface, materials that are not typically found in asteroids or comets. This could suggest that the object was either designed or altered in some way. If it is artificial, it would be the first confirmed interstellar object that was not the product of natural forces. There is also the question of the object's age and its journey to our solar system. If 3I/Atlas is a piece of a larger technological structure, how long has it been travelling through space? Has it been on its interstellar journey for millions of years, or is it a relatively recent creation from a technologically advanced civilization? Loeb's hypothesis challenges us to think beyond the traditional boundaries of space and time. What if objects like 3I/Atlas are part of a long-term effort to explore the universe, sent out by alien civilizations in a manner that is completely beyond our comprehension? The idea that 3I/Atlas could be artificial is certainly an unconventional one, and it has been met with skepticism by many in the scientific community. Critics argue that there is no definitive evidence to support the idea that the object is anything other than a natural interstellar object, and that its strange behaviour can be explained by more conventional astronomical phenomena. For example, The brightening of 3I/Atlas could be the result of its irregular shape, or a result of gases escaping from a porous surface as it warmed up near the Sun, rather than an indication of artificial materials. However, the fact that 3I/Atlas does not fit neatly into any of these conventional categories, its trajectory, its unexpected behaviour, and its high reflectivity suggests that we may be looking at something much more complex. Loeb's theory, although speculative, pushes us to think outside the box and entertain the possibility that 3I/Atlas could be something far more significant than just another asteroid or comet. As scientists continue to observe 3I/Atlas and gather more data, the questions about its origins will only become more pressing. Could it be a natural object that has been shaped by unusual forces? Could it be a fragment of a lost or destroyed planet? Or is it a piece of technology sent from an advanced civilization, travelling across the cosmos in search of new worlds to explore? For now, the mystery remains unsolved. But one thing is certain: the more we learn about 3I/Atlas, the more questions arise about its true nature, and its presence in our solar system challenges us to reconsider what we know about the universe. The discovery and study of interstellar objects like 3I/Atlas have only become possible thanks to remarkable advancements in space telescope technology. These instruments serve as our eyes into the cosmos, allowing us to detect and track objects that would otherwise go unnoticed. In the case of 3I/Atlas, the PAN-STARRS, Panoramic Survey Telescope and Rapid Response System, played a crucial role in its detection. Without such state-of-the-art technology, astronomers wouldn't have been able to pinpoint the object's trajectory, speed, and peculiar characteristics. PAN-STARRS, located in Hawaii, is one of the most advanced sky survey systems in the world, designed to monitor the night sky for transient objects like asteroids, comets, and supernovae. Its wide-field survey capability enables it to track objects as they move across the sky. The system identifies those heading toward Earth or passing through the solar system. The importance of PAN-STARRS in detecting 3I/Atlas cannot be overstated. It was the first to spot this interstellar visitor, setting the stage for the subsequent study. However, PAN-STARRS is not the only telescope involved in observing objects like 3I/Atlas. Over the years, many observatories have contributed to tracking and studying interstellar objects. For instance, the European Space Agency's ESA Gaia satellite has provided valuable data on the positions and motions of stars, which helps understand the origins of interstellar visitors. With more telescopes and satellites launched each year, the capability to study such objects is rapidly improving. The real leap in technology, however, comes with next-generation observatories and specialized instruments designed to capture detailed information about these objects. The James Webb Space Telescope, JWST, set to be fully operational in the coming years, will bring unprecedented resolution and sensitivity to the study of distant celestial objects. JWST is designed to observe infrared light, which is particularly useful for studying objects like 3I/Atlas, whose surface temperatures and emissions may be best understood in the infrared spectrum. By capturing infrared data, JWST could provide deeper insights into the composition, structure, and behaviour of interstellar objects passing through our solar system. In addition to optical and infrared observations, radio astronomy plays a crucial role in studying objects like 3I/Atlas. Instruments such as the Very Large Array, VLA, in New Mexico, and the upcoming Square Kilometre Array, SKA, being built in Australia and South Africa, will allow astronomers to detect radio emissions from interstellar objects. These emissions could offer clues about the object's composition and even its origins. For example, radio signals that do not fit known patterns could suggest the object is actively transmitting information, perhaps even a sign of an artificial source. Even with these advanced technologies, studying interstellar objects presents unique challenges. Their high speed and distant origins mean astronomers often have a brief window to track them before they move beyond our detection range. This is why rapid response systems like PAN-STARRS are crucial. They provide the ability to detect objects quickly and track them in real time. For 3I/Atlas, this meant that astronomers had to work fast to gather as much data as possible, while the object was still within the solar system's reach. While current technology has allowed us to make tremendous strides in tracking and observing objects like 3I/Atlas, much remains unknown. For example, We have yet to fully understand why certain interstellar objects such as 3I/Atlas and Oumuamua exhibit strange behaviours that defy natural explanations. Some scientists argue that current telescopes and instruments lack the sensitivity required to detect all possible signals these objects might be emitting. To make significant progress, we'll need to push the boundaries of observational technology even further. Loeb's theory about 3I/Atlas being a piece of alien technology underscores the need for better instruments to study these objects. If interstellar objects like 3I/Atlas aren't just natural phenomena, but could be artificial, the implications for our search for extraterrestrial intelligence, SETI, would be profound. The possibility that alien probes or artifacts might be travelling through our solar system would require a new kind of technology, a combination of optical, infrared, and radio instruments capable of detecting faint and unusual signals. The study of 3I/Atlas and other interstellar objects is at the forefront of a revolution in space exploration. As we develop more advanced telescopes, spacecraft, and detection systems, our understanding of objects from other star systems will expand. These tools will help us unlock the mysteries of the universe, perhaps even revealing signs of intelligent life elsewhere in the galaxy. With each new technological advancement, we get closer to answering the questions raised by objects like 3I/Atlas. Will we find evidence of alien technology? Will we learn more about the nature of interstellar travel and how objects from other star systems interact with our solar system? Only time will tell, but one thing is certain. The role of space telescopes and technology in this pursuit will be indispensable. The future of our understanding of the universe depends on the tools we develop today. Avi Loeb's theory that 3I/Atlas might be a permanent resident of our solar system is not just a bold claim. It represents a paradigm shift in the way we approach the study of interstellar objects. The ramifications of Loeb's ideas extend far beyond the specifics of 3I/Atlas itself. If his theory is correct, it could fundamentally alter the course of astrophysics, shifting the focus of our research from simply cataloguing and studying transient objects to exploring the possibility that objects from other star systems could become integrated into our own cosmic environment. The primary challenge Loeb's theory presents is a challenge to the very assumptions that underpin our understanding of the solar system. For decades, scientists have believed that interstellar objects like 3I/Atlas are passing through our solar system on a one-way journey, never to return. These objects are fleeting visitors, and once they've passed through, they're gone. This view has been reinforced by the lack of evidence suggesting that the Sun's gravity could capture such objects. But Loeb's theory calls that assumption into question, suggesting that gravitational capture may be more common than previously thought. If it turns out that interstellar objects can be captured by the Sun's gravity and remain in the solar system for extended periods, this would open up entirely new avenues of research. Scientists would have to rethink how they model the dynamics of our solar system, taking into account the potential for interactions with objects from other star systems. This could lead to the discovery of more long-term interstellar visitors, which in turn could shed light on the nature of the universe beyond our solar system. Loeb's theory also has profound implications for the search for extraterrestrial life. If 3I/Atlas is artificial, it could represent the first concrete evidence of technology from another civilization. This would be a watershed moment in the search for intelligent life beyond Earth, a discovery that could fundamentally change the way we view our place in the universe. Loeb's work has already sparked interest in the possibility of other interstellar objects being probes or artifacts from alien civilizations, and this line of inquiry could grow into a major field of research. But even if 3I/Atlas is ultimately found to be a natural object, Loeb's theory forces us to think more critically about the role of interstellar objects in our solar system. The idea that such objects might be captured by the Sun or otherwise interact with our solar system's gravity means that we must consider the impact these objects might have on our solar system over time. Could they influence the orbits of planets or moons? Could they serve as a source of new material for study, offering clues about the composition of other star systems? The impact of Loeb's theory extends into space exploration as well. If it becomes clear that objects from other star systems could be captured by the Sun, this opens up the possibility of future space missions targeting these objects. For the first time, we might have the opportunity to study an interstellar object up close, gaining unprecedented insights into its composition, structure, and potentially even its origins. Space agencies might begin to shift their focus to interstellar objects as key targets for exploration, especially if they are thought to contain material from other stars or, in the case of Loeb's theory, evidence of extraterrestrial technology. Beyond the scientific community, Loeb's ideas also challenge the way we think about humanity's role in the cosmos. If interstellar objects can be captured and integrated into our solar system, it raises the possibility that other civilizations might have been interacting with our solar system for much longer than we realize. Could we be a part of a much larger network of interstellar exploration? What does it mean for our understanding of life in the universe if we find out that objects from other civilizations are already among us? Even though Loeb's theories are controversial and far from universally accepted, they have undoubtedly ignited a new line of inquiry in astrophysics and the search for extraterrestrial intelligence. His willingness to entertain ideas that others might dismiss has forced the scientific community to rethink its assumptions about the universe. Whether or not Loeb's theories about 3I/Atlas are proven true, they have expanded the boundaries of astrophysics, and they could have far-reaching consequences for how we approach space research in the future. As we continue to study 3I/Atlas and similar objects, Loeb's work will undoubtedly remain a point of contention and inspiration. His bold ideas have reshaped the conversation around interstellar objects, and his influence on the field will likely be felt for many years to come. Whether we ultimately find evidence of extraterrestrial technology, or simply gain a better understanding of the dynamics of our solar system, Loeb's contributions have paved the way for a new era of cosmic exploration. The discovery and study of interstellar objects like 3I/Atlas have raised a fascinating and controversial question. Could this object be an extraterrestrial probe? Avi Loeb, an astronomer known for challenging conventional scientific thinking, has proposed that 3I/Atlas might not just be a natural phenomenon. According to Loeb, this object could be a technological artifact, perhaps an ancient probe, or even a piece of alien technology travelling through our solar system. While this idea may seem speculative, it forces us to rethink the search for extraterrestrial intelligence, SETI, and how we define signs of alien life. Loeb's hypothesis about 3I/Atlas stems from the object's strange characteristics, which set it apart from typical comets and asteroids. First, there's the object's speed. Interstellar objects like 3I/Atlas are expected to travel quickly due to their high velocities, but this particular object's movement was unusual. Its trajectory seemed to defy expectations, suggesting that it was not merely passing through, but potentially being captured by the sun's gravity. Loeb proposes that this could be the result of intentional interstellar navigation. Perhaps 3I/Atlas was deliberately slowed and directed towards our solar system. Another striking feature is the object's unusual brightness. As 3I/Atlas passed through our solar system, it exhibited a brightness much greater than expected for an object of its type. This led Loeb to suggest that the object might be constructed with highly reflective materials, which is uncommon in natural asteroids or comets. Loeb posits that such reflective surfaces could be the result of artificial design, created intentionally to stand out as it passed through various star systems. If these materials are indeed artificial, 3I/Atlas would be the first confirmed interstellar probe, a discovery that could revolutionize our understanding of extraterrestrial technology. Loeb's theory extends beyond 3I/Atlas, proposing that this object might not be a one-off occurrence. If 3I/Atlas is indeed a probe, it opens up the possibility that other interstellar objects could have similar artificial origins. Loeb suggests that this might be the beginning of a trend where objects from advanced civilizations are sent out across the universe to explore new star systems. These probes could be collecting data, searching for life, or even attempting to make contact with other civilizations. In this context, 3I/Atlas could be the first tangible evidence of such interstellar exploration. Loeb's theory challenges the traditional approach to SETI. Instead of focusing solely on signals or radio waves as potential evidence of extraterrestrial intelligence, Loeb suggests that we should broaden our search to include physical objects. This new frontier in SETI research would shift the focus from listening for transmissions from distant stars to actively looking for physical evidence of alien technology in our own solar system. However, Loeb's theory remains highly speculative, and many in the scientific community remain skeptical. Some argue that the unusual characteristics of 3I/Atlas can be explained by natural phenomena, such as the release of gas from a comet or the aftermath of a collision in space. While Loeb acknowledges these alternative explanations, he points out that the improbability of the object's properties warrants further investigation. If 3I/Atlas is artificial, it would represent the first confirmed interstellar object of its kind, raising fundamental questions about the nature of life and technology beyond Earth. The implications of Loeb's theory are profound. If 3I/Atlas is indeed an interstellar probe, it would be the first direct evidence of extraterrestrial technology, suggesting that we are not alone in the cosmos. This discovery would mark a new era in the search for extraterrestrial intelligence, prompting complete rethinking of our place in the universe. It would also catalyze new lines of scientific inquiry and space exploration, with potentially life-changing consequences for humanity. Even if 3I/Atlas turns out to be a natural object, Loeb's theory still raises important questions about the potential for interstellar exploration. The idea that objects from other star systems might be captured by the Sun and studied within our solar system challenges traditional approaches to space exploration. Rather than sending spacecraft to distant stars, we could be studying the objects that come to us, objects that may hold valuable clues about the origins of the universe, the formation of star systems, and the potential for life elsewhere. As scientists continue to study 3I/Atlas, the question of whether it is an alien probe will likely remain central to the debate. If the object is indeed artificial, it could mark the beginning of a new chapter in SETI, one where interstellar objects like 3I/Atlas provide the answers to some of the greatest mysteries of the universe. Regardless of the outcome, Loeb's theory has already expanded our imagination and pushed the boundaries of what we consider possible in the search for extraterrestrial life. Avi Loeb's theory that 3I/Atlas could be captured by the Sun represents a radical departure from conventional thinking about how interstellar objects behave within our solar system. To understand why Loeb's idea is so groundbreaking, we must first explore the concept of gravitational capture, a process rarely discussed in the context of interstellar objects. Gravitational capture occurs when an object from outside a star system enters the gravitational field of that star. Instead of escaping, the object is slowed down enough to be pulled into orbit around the star, a phenomenon typically observed with planets, moons, and other objects within a star system. However, the possibility that a star's gravity could capture an interstellar object challenges our understanding of how objects move through space. Interstellar objects like 3I/Atlas typically travel at extremely high speeds, far faster than objects originating within our solar system. These high velocities make it unlikely that the Sun's gravity could capture such objects. They usually pass through the solar system, continuing their journey into interstellar space. The Sun's gravitational field is not strong enough to slow down a high-speed object sufficiently for it to be trapped in orbit. For an object to be captured, it needs to approach the Sun at the right angle and speed so that its trajectory is altered just enough to allow the Sun's gravity to slow it down without it being flung back into deep space. Loeb argues that 3I/Atlas may have encountered the right combination of conditions for the Sun's gravity to have successfully captured it. According to his theory, 3I/Atlas's unusual trajectory and speed, combined with the subtle effects of the Sun's gravitational field, could have slowed it down enough to prevent its escape. Rather than simply passing through, 3I/Atlas may have been gradually pulled into the Sun's gravitational influence, allowing it to remain within our solar system longer than expected. Gravitational capture is not a completely unknown phenomenon. Scientists have considered it in the context of other cosmic interactions, such as the dynamics of galaxies and star clusters. There are examples where entire star systems have been captured by larger galaxies, but the idea that a star like the Sun could capture an interstellar object, especially one travelling as quickly as 3I/Atlas, hasn't been seriously explored until now. Loeb's theory challenges this traditional assumption and proposes that the Sun might have the capacity to capture high-velocity objects like 3I/Atlas. To understand how this process might work, it's important to consider the forces at play when an object enters a star system. The object's initial speed and trajectory are determined by its motion through interstellar space. As it approaches the Sun, its trajectory is influenced by the Sun's gravitational field. While the Sun's gravity typically cannot capture interstellar objects, it can still alter their paths, especially if the object passes close enough to the Sun or another massive body within the solar system. As the object moves through the Sun's gravitational field, it may lose some of its speed, allowing it to be gradually pulled into orbit. Loeb suggests that gravitational capture might be more common than previously thought. He believes that objects like 3I/Atlas could be slowed by the Sun's gravity and captured, even at high speeds, if their velocity and path align just right. This idea opens new ways of thinking about the behaviour of interstellar objects and the dynamics of our solar system. Loeb's theory raises important questions about the future of space exploration and our understanding of the solar system. If 3I/Atlas is captured by the Sun, it could be the first of many interstellar objects drawn into our solar system. This raises the possibility that more objects from other star systems could be captured in the future. Understanding the dynamics of gravitational capture could change how we approach the study of interstellar objects and the potential for long-term scientific exploration. Furthermore, Loeb's hypothesis challenges our perception of the solar system's isolation. Traditionally, we think of the solar system as a self-contained unit, separate from the rest of the galaxy. However, the idea that interstellar objects could be captured by the Sun suggests that our solar system might be more interconnected with the larger universe than we previously thought. The Sun's gravity could act as a hub, drawing objects from distant stars and providing a unique opportunity to study these interstellar visitors up close. If Loeb's theory proves correct, it would significantly alter our understanding of the solar system and the nature of interstellar objects. Gravitational capture would not just be a theoretical curiosity, it could become a key concept in the study of objects from other star systems. As we continue to study 3I/Atlas and other interstellar objects, Loeb's ideas may offer valuable insights into the dynamics of our solar system and the broader cosmic environment. The possibility that these objects can be captured by the Sun opens new frontiers in our exploration of the universe and our place within it. If Avi Loeb's theory that 3I/Atlas could be captured by the Sun proves true, it would have profound implications for space exploration. This possibility opens a new frontier for how we interact with objects outside our solar system and could revolutionize interstellar exploration. Instead of simply passing through, objects from other star systems could become targets for study and exploration within our own cosmic neighborhood. Space exploration has traditionally focused on missions within our solar system, targeting planets, moons, and other celestial bodies that orbit the Sun. Although there has been significant interest in distant exoplanets and the search for extraterrestrial life, the idea of studying an interstellar object within our solar system has remained theoretical rather than practical. If Loeb's theory holds, 3I/Atlas would offer the first opportunity for humanity to study an interstellar object up close. This object, having travelled vast distances, may provide vital information about the composition, history, and forces that shape distant star systems. It could yield clues that we cannot obtain through traditional space exploration methods, making it a unique scientific opportunity. The implications for space exploration would be immense. If 3I/Atlas were to become a long-term resident of our solar system, it could be a target for future space missions. Probes, rovers, or even manned spacecraft could be sent to investigate the object in detail. A mission to 3I/Atlas could allow us to collect interstellar samples, a task that would be far more difficult to achieve through traditional methods like sending probes to distant exoplanets. Studying 3I/Atlas could also provide insight into the formation and evolution of star systems. Having travelled across multiple star systems before entering ours, it could offer valuable information about the material that forms distant stars, planets, and moons. This could expand our understanding of the similarities and differences between our solar system and others in the galaxy, helping us learn how celestial bodies form and evolve. The capture of 3I/Atlas by the Sun would also present new opportunities to study the dynamic nature of star systems. If gravitational capture is possible, interstellar objects may interact with solar systems more frequently than previously thought. This raises the prospect of more interstellar objects entering our solar system in the future, offering new targets for study. If we learn how to predict and track these objects, we could seize the opportunity to investigate them and uncover secrets about the universe that are currently beyond our reach. One of the most exciting possibilities Loeb's theory suggests is that 3I/Atlas could be a relic of an ancient alien civilization. If true, it would be the first evidence of extraterrestrial intelligence, a groundbreaking discovery. A technological artifact from another star system would reshape our understanding of the universe, shifting the focus of space exploration. Rather than looking for signs of life on distant planets, we could begin focusing on interstellar objects within our own solar system, searching for traces of alien technology or artifacts that could reveal more about life in the galaxy. Even if 3I/Atlas turns out to be a natural object, its study could still provide valuable insights into the conditions that support life. By understanding the environments of other star systems and comparing them to our own, we could gain new perspectives on the potential for life beyond Earth. We might learn about the chemistry of interstellar space, the composition of distant star systems, and the forces that shape planetary systems, knowledge that could inform our search for habitable exoplanets. For space agencies like NASA, ESA, and private companies, the potential to study interstellar objects like 3I/Atlas represents an exciting new frontier. Future missions to study such objects would likely require advancements in spacecraft technology, such as faster propulsion systems, more sensitive detection instruments, and autonomous systems capable of operating far from Earth. These advancements would not only aid in the study of interstellar objects, but also push the boundaries of human exploration in ways we've never attempted. The study of 3I/Atlas could also foster new collaborations in space exploration. If space agencies agree that capturing interstellar objects is feasible, it could lead to international missions to explore these objects in more detail. This could drive the development of new tools, methodologies, and strategies for studying objects from beyond our solar system, spurring innovation in space science. Ultimately, Loeb's theory about 3I/Atlas being captured by the Sun could transform space exploration, expanding our goals and opening new frontiers in our search for knowledge. Whether 3I/Atlas turns out to be a natural object, a probe, or something else entirely, it could signal the start of a new era in space exploration, where studying interstellar objects becomes a key focus in understanding the universe. As 3I/Atlas continues its journey through the solar system, its future remains uncertain. Initially, many astronomers expected it to pass through without much consequence, but Avi Loeb's bold theory raises the possibility that 3I/Atlas could become a long-term resident of our solar system. If this occurs, it could stay within our cosmic neighbourhood for decades or even centuries, presenting both exciting opportunities and significant challenges for scientists working to understand its nature and potential impact on our solar system. One of the key questions is whether 3I/Atlas will remain bound by the Sun's gravity, or eventually break free to continue its journey through the galaxy. Its trajectory will be influenced by several factors, including the gravitational pull of other planets and the Sun itself. It's possible that 3I/Atlas could enter a stable orbit around the Sun, becoming part of the solar system's family of objects. Alternatively, it might escape, continuing its journey into the vastness of space and never to be seen again. If 3I/Atlas does remain within the solar system, it would offer an unprecedented opportunity for scientific study. Having the chance to track and study the object over an extended period would allow scientists to collect data about its composition, structure, and origin. For example, its interactions with the Sun and other celestial bodies could provide valuable insights into how interstellar objects behave when they enter a new solar system. Understanding how 3I/Atlas is affected by the Sun's gravity and solar wind could shed light on the dynamics of space travel and interstellar navigation. Furthermore, if 3I/Atlas turns out to be artificial, perhaps a probe from an extraterrestrial civilization, it could provide a unique opportunity to study alien technology. For decades, scientists have searched for signs of extraterrestrial intelligence, and the discovery of a probe or artifact from another star system would be a groundbreaking achievement. If 3I/Atlas is a product of alien engineering, it would completely redefine our understanding of the universe. This discovery could revolutionize not only astrophysics, but also fields such as biology, technology, and even philosophy. The possibility of 3I/Atlas remaining in the solar system also raises exciting prospects for future space missions. If the object stays within the Sun's gravitational reach, it could become a target for spacecraft missions. Sending probes or robotic explorers to 3I/Atlas would allow us to collect physical samples, conduct detailed analysis, and learn more about its origins and purpose. This would mark a new chapter in humanity's quest to understand objects from beyond our solar system, and could provide valuable data for future missions to distant stars and planets. However, If 3I/Atlas escapes the Sun's gravity and continues its journey through space, it would become just another fleeting object in the vast galaxy. In this scenario, the study of 3I/Atlas would be limited to the data we've already collected, and opportunities for direct study would be lost. Even so, its brief visit could still have a lasting impact on space science. The data gathered during its flyby will likely influence our understanding of interstellar objects for years, helping to refine our models of how these objects behave and how they might interact with our solar system. The fate of 3I/Atlas also raises broader questions about the future of space exploration. Could this be the first of many interstellar objects to enter our solar system? If Loeb's theory about gravitational capture is correct, it may mean that more interstellar objects could be captured by the Sun in the future, providing further opportunities for study. These objects could offer invaluable insights into the diversity of star systems, the nature of interstellar space, and even the possibility of life beyond Earth. As scientists continue to monitor 3I/Atlas, the next few years will be crucial in determining whether it stays in our solar system or continues its journey into interstellar space. Regardless of its fate, the scientific community will continue to study the object from every angle, gathering as much data as possible to answer the many questions it has raised. 3I/Atlas represents a rare opportunity, one that may not come again for many years, and scientists will explore every possibility to unlock the mysteries it holds. Whether 3I/Atlas remains in our solar system or quickly exits, it has already made a significant mark on the field of astronomy. Its presence challenges many of our assumptions about interstellar objects, and its study has the potential to reshape our understanding of the universe. Although its future is uncertain, the journey of 3I/Atlas through our solar system has sparked a conversation that will continue for years to come. Avi Loeb's theory that 3I/Atlas could be captured by the Sun represents a radical departure from conventional thinking about how interstellar objects behave within our solar system. The idea that such an object might be a probe sent by an alien civilization fascinates and unsettles many. Loeb's bold and speculative claims have captured the public's imagination, but they have also sparked skepticism and confusion about what we truly know and don't know about 3I/Atlas. Loeb, a seasoned astrophysicist known for challenging conventional thinking, has long argued that some interstellar objects could be artificial. His earlier theory about Oumuamua ignited interest, and now his suggestion that 3I/Atlas might be a probe or even alien technology has made waves in both scientific and popular media. Loeb argues that scientists should remain open to unconventional explanations and not dismiss the extraordinary potential of objects like 3I/Atlas, just because they don't fit into current scientific models. His audacity in proposing that 3I/Atlas could be an extraterrestrial artifact has led to public debates about life in the universe and the possible existence of advanced civilizations beyond our solar system. However, many in the scientific community remain cautious. While the idea that 3I/Atlas could be artificial is intriguing, it remains speculative and far from proven. Critics of Loeb's theory argue that while the object's behavior is unusual, it is still likely a natural interstellar object. For example, 3I/Atlas's rapid brightening, often cited as evidence of artificial materials, can also be explained by natural processes such as the sublimation of gases from a comet or dust reflecting sunlight. Similarly, its trajectory, though anomalous, can be explained by the dynamics of interstellar objects interacting with gravitational fields. Critics view Loeb's theory as overly speculative, lacking the necessary evidence to support claims of extraterrestrial technology. The media, meanwhile, amplifies the most sensational aspects of Loeb's ideas, framing them as science fiction. This can lead to a disconnect between what scientists understand and what the public perceives. The narrative of alien probes or extraterrestrial technology is undeniably captivating. Who wouldn't be excited by the possibility of first contact with an alien civilization? However, such interpretations, while enticing, can obscure the more nuanced aspects of scientific investigation into 3I/Atlas. The reality is that while Loeb's theories are thought-provoking, they are not universally accepted, and much of the research remains focused on gathering data and refining our understanding of the object's natural characteristics. This discrepancy between public perception and scientific reality highlights the broader challenge science faces when communicating complex speculative ideas. scientific discoveries often unfold slowly, with evidence building incrementally over time. In contrast, media coverage tends to favour immediate eye-catching conclusions, especially when the subject involves potentially groundbreaking discoveries. As a result, the public may jump to conclusions before scientists have fully explored the object's properties and behaviours. While some may enthusiastically embrace the idea of 3I/Atlas as an alien probe, others may dismiss the concept as fantastical, overlooking the scientific process behind Loeb's reasoning. Public perception is also influenced by cultural factors. The idea of extraterrestrial life is a staple of popular culture, appearing in everything from movies and TV shows to books and documentaries. This widespread interest shapes how people interpret scientific ideas. When Loeb suggests 3I/Atlas might be artificial, many people's minds may immediately jump to images of flying saucers or alien space missions. In this way, the public's perception of 3I/Atlas is shaped not only by scientific evidence but by societal narratives about space, life beyond Earth, and the unknown. For scientists, the challenge lies in navigating the tension between public curiosity and scientific caution. While it's important to entertain unconventional ideas and encourage exploration of new hypotheses, scientists must also differentiate between speculation and evidence. The media's portrayal of Loeb's ideas as fact, especially when they lean heavily into sensationalism, can lead to misunderstandings about the researcher's status. While 3I/Atlas may eventually provide groundbreaking insights, it's crucial to emphasize that much of what we know now is still preliminary. Until more data is gathered and analyzed, we cannot definitively say whether 3I/Atlas is a natural object, an artificial probe, or something else entirely. This disconnect between the scientific community and the public also raises broader questions about how science is communicated. As we continue to study objects like 3I/Atlas, it's essential to bridge the gap between public fascination and scientific investigation. The future of space exploration and the search for extraterrestrial intelligence will likely continue to stir popular interest. However, it's important for the scientific community to present these ideas with caution, tempering excitement with skepticism. Only through careful study and rigorous data collection will we be able to answer the questions Loeb and others have raised. Questions that could reshape our understanding of the universe, life, and humanity's place in the cosmos. As 3I/Atlas continues its journey through our solar system, its mysterious nature and the bold theories surrounding it remain at the forefront of scientific inquiry. Avi Loeb's hypothesis that the object could be captured by the sun or even be an artificial probe sent by an advanced extraterrestrial civilization has opened up a vast realm of possibilities that challenge conventional thinking in astrophysics. Whether 3I/Atlas is a fragment of a shattered star system, a natural interstellar visitor, or something far more extraordinary, its presence in our solar system has sparked renewed interest in interstellar objects and their potential impact on our understanding of the universe. Loeb's suggestion that 3I/Atlas could be captured by the sun, a concept once considered highly unlikely, forces us to reconsider the dynamics of our solar system and how we interact with objects from beyond our cosmic neighbourhood. If Loeb's theory proves correct, it would not only mark a breakthrough in our understanding of gravitational interactions, but also open up new opportunities for studying interstellar objects in unprecedented detail. The possibility of studying an object from another star system up close, whether it's a natural object or a relic of alien technology, represents a transformative moment in space exploration. The broader implications of Loeb's theory extend beyond the study of 3I/Atlas itself. It challenges the assumptions that have long dominated our understanding of how objects from other star systems behave when they encounter our solar system. If gravitational capture is indeed a real phenomenon, it could mean that more interstellar objects will visit, stay, and even become part of our solar system in the future. This could revolutionize the field of astrophysics, leading to new discoveries about the composition of distant star systems, the dynamics of interstellar space, and even the potential for life beyond Earth. At the heart of the mystery of 3I/Atlas lies a fundamental question: how much do we truly understand about the universe? Every new discovery about the object, whether it supports or challenges Loeb's theory, forces us to confront the limits of our knowledge. If 3I/Atlas is indeed an artificial object, it would provide the first concrete evidence of extraterrestrial technology, forever altering our view of life in the universe. Even if it turns out to be a natural object, the fact that it has entered our solar system from interstellar space challenges our assumptions about the interactions between stars and their surrounding environments. The mystery of 3I/Atlas also raises important questions about the future of space exploration. How might we study objects from other star systems in the future? What kinds of technologies will we need to develop in order to track and explore interstellar visitors? The possibility that 3I/Atlas could remain in our solar system for an extended period of time opens up exciting new possibilities for scientific study. Future space missions could be designed to investigate these objects in greater detail, potentially providing us with a wealth of information about the origins and nature of interstellar objects and even the potential for life elsewhere in the galaxy. The study of 3I/Atlas could also lead to advances in space exploration technology. To investigate an object from another star system, scientists would need to develop new tracking systems, propulsion technologies, and methods for remote exploration. Such advancements could have far-reaching implications, not only for studying interstellar objects but also for missions to other planets and stars. As humanity moves toward an era of interstellar exploration, the tools and techniques developed to study 3I/Atlas could lay the groundwork for exploring even more distant regions of space. For now, the journey of 3I/Atlas is far from over. As astronomers continue to monitor its trajectory and collect data, the object remains an enigma, one that challenges the boundaries of our knowledge and invites us to think in new ways about the universe. Whether it is a piece of alien technology or just another interstellar visitor, 3I/Atlas has already made an indelible mark on the field of astrophysics, sparking debate, curiosity, and excitement about the future of space exploration. In the coming years, the study of 3I/Atlas will undoubtedly continue to shape our understanding of interstellar objects and the solar system itself. While we may not have all the answers yet, the journey of 3I/Atlas serves as a reminder that the universe is full of surprises, mysteries, and untapped possibilities. It highlights that in the vastness of space, there is still much to be discovered, and that every new discovery, no matter how small, adds a piece to the cosmic puzzle that we're only beginning to understand. With the increasing frequency of interstellar objects passing through our solar system, the study of these cosmic visitors is no longer a niche area in astronomy. It has become a critical field of research. Avi Loeb's theory about 3I/Atlas potentially staying in our solar system has sparked a shift in how scientists are approaching interstellar objects. Rather than merely cataloguing objects that pass through and then vanish, there is now a growing focus on understanding how these objects interact with our solar system, how they behave, and what they can teach us about the nature of interstellar space. One significant factor driving this shift is the rapid advancement of telescope and observational technologies. In the past, detecting interstellar objects like 3I/Atlas was a rare event. However, with tools like Pan-STARRS, the Vera C. Rubin Observatory, formerly known as the LSST, and the upcoming James Webb Space Telescope, JWST, astronomers will be able to more frequently identify and track interstellar objects as they approach. These advanced telescopes can detect smaller objects from farther distances, enabling scientists to track their trajectories and analyze their composition long before they enter our solar system. With these technologies, researchers can gain more insight into the nature of interstellar visitors, setting the stage for more informed studies and deeper exploration. In addition to improvements in observational tools, spacecraft missions are likely to play a pivotal role in this new wave of interstellar research. Just as we have sent probes to study asteroids and comets within our solar system, future missions may involve sending probes to explore interstellar objects. These spacecraft could study the composition, structure, and behavior of objects like 3I/Atlas up close, providing crucial information about the processes that govern interstellar space. More importantly, such missions could also offer us clues about the origins of life and whether similar processes might occur elsewhere in the universe. This would be a major step in advancing our understanding of the cosmos and our place within it. To explore interstellar objects, advancements in propulsion technology will be necessary. Objects passing through our solar system are often fleeting, making it essential to develop spacecraft capable of traveling vast distances quickly and efficiently. New propulsion technologies, such as solar sails or nuclear thermal propulsion, could enable space missions to reach these objects in a practical timeframe. These innovations will be vital for ensuring that we can explore interstellar visitors before they leave our solar system. In addition, new methods for collecting and analysing data remotely, such as autonomous rovers or drones that could land on and explore the surface of objects like 3i/Atlas, will allow for more detailed and insightful studies. The growing interest in interstellar objects and the potential to study them more closely also raises the possibility that our understanding of the universe at large may undergo a fundamental shift. If objects like 3i/Atlas are captured by the Sun more frequently, they could provide valuable insights into the composition of other star systems. For example, these objects might contain material from distant planets, moons, and atmospheres, information that could revolutionize our knowledge of how planetary systems form and evolve. Such discoveries could also offer clues about the conditions that support life, helping scientists refine the search for habitable environments in other star systems. As we continue to study interstellar objects, the long-term implications could reshape not just our scientific understanding, but also our broader perspective on space exploration. Embracing the idea that our solar system may not be as isolated as we once thought opens the door to a future where exploring and studying interstellar objects becomes a central focus of scientific endeavour. Loeb's theory about 3i/Atlas could be a significant turning point, pushing the scientific community to reconsider old assumptions and explore new possibilities. With each new discovery, we move closer to a deeper understanding of the universe and the forces at play beyond our solar system. In conclusion, the future of interstellar object research holds immense promise. As technology continues to evolve, and as our capacity to explore and study interstellar visitors improves, we stand at the precipice of a new era in space exploration. Whether studying natural interstellar objects like 3i/Atlas or searching for signs of alien technology, the field promises exciting discoveries that could shape our understanding of the universe for generations to come. By looking beyond our solar system, we open new frontiers of scientific exploration that could reveal the mysteries of distant star systems and provide us with insights that may ultimately answer some of humanity's oldest questions about the cosmos. For much of the 20th century, the idea of objects coming from other star systems was confined to speculation and science fiction. It wasn't until the discovery of Oumuamua in 2017 that the scientific community began to seriously consider the possibility of interstellar objects entering our solar system. Since then, the discovery of 3i/Atlas has confirmed that our solar system is not a static, isolated entity. It is actively interacting with the larger cosmos in ways once imagined only in fiction. Theories about interstellar objects have rapidly evolved in recent years. Early models treated such objects as transient visitors, brief encounters with little lasting impact on our solar system. These objects were considered rare anomalies in the cosmic landscape. However, as more interstellar objects have been discovered, scientists are revisiting this view. Loeb's theory that 3i/Atlas could remain in our solar system for an extended period reflects a broader shift in how we understand these objects. Instead of seeing them as fleeting interlopers, we are now recognizing a more complex relationship between our solar system and interstellar space. While some scientists still believe most interstellar objects will simply pass through and continue their journey, the growing number of discoveries suggest a more intricate reality. Could our solar system be attracting more interstellar objects than previously thought? Are these objects part of a much larger, more frequent phenomenon than originally imagined? These are the questions scientists are grappling with. As more evidence is gathered, it's becoming clear that our understanding of interstellar space needs to be recalibrated. The implications of this shift could significantly alter how we view the structure and dynamics of our galaxy. Theories about the origins of interstellar objects have also expanded. Initially, astronomers believed objects like Oumuamua and 3i/Atlas were rare anomalies, unique in some way. These were seen as isolated incidents, unusual enough to spark interest but not indicative of a broader trend. However, the scientific community is now entertaining the possibility that interstellar objects might be far more common than previously thought. The discovery of multiple interstellar objects has led scientists to rethink how often these objects enter our solar system and how they interact with their environment. This shift is not just expanding the scope of our research into the cosmos, but is also reshaping our expectations for future discoveries. As the search for interstellar objects continues, the scientific community recognizes the potential for deeper exploration and understanding of these cosmic visitors. With advancements in observational technology, such as the Pan-STARRS, Vera C. Rubin Observatory, and the upcoming James Webb Space Telescope, JWST, astronomers will be able to track and study interstellar objects with greater frequency and precision. The ability to identify and analyze these objects early in their journey will provide invaluable insights into their composition, behavior, and origin. Loeb's theory about the potential for interstellar objects to remain in our solar system for extended periods opens exciting new avenues for exploration. If objects like 3I/Atlas are captured by the Sun or held in orbit longer, they could provide a treasure trove of data about the material makeup of distant star systems. These objects could offer glimpses into the composition of planets, moons, and potential habitable environments in other parts of the galaxy. The prospect of studying these objects closely could transform our understanding of the processes that govern the formation of star systems and planetary bodies. Loeb's ideas, though controversial, are pushing the boundaries of our knowledge and encouraging astronomers to think more boldly about the implications of interstellar objects. His work has sparked a renaissance in the study of interstellar space, promising exciting new insights into the nature of the universe. Whether these objects are natural or artificial, fragments of shattered star systems or ancient technological relics, they challenge us to think about the cosmos in new and innovative ways. As scientists continue refining their models of how interstellar objects interact with our solar system, new theories about their origins, behavior, and potential technological significance will continue to emerge. These theories will stretch the limits of our knowledge and may one day lead to groundbreaking discoveries that reshape our understanding of space and our place in the universe. The study of interstellar objects is no longer a peripheral pursuit in astronomy. It is rapidly becoming one of the most exciting and dynamic fields of research, with the potential to unlock new mysteries about the cosmos and the origins of life. In conclusion, the discovery of 3I/Atlas and the growing body of research surrounding interstellar objects are reshaping how we think about space and our relationship with the larger universe. As we continue studying these objects, the future promises exciting discoveries that could transform our understanding of the cosmos and spark new possibilities for exploration. One of the most intriguing aspects of studying interstellar objects like 3I/Atlas is the possibility that they could provide evidence of extraterrestrial life. While this may seem speculative, the fact that 3I/Atlas is travelling from another star system raises fundamental questions about the potential for life beyond Earth. Could 3I/Atlas be carrying the building blocks of life, or perhaps even signs of intelligent life? Avi Loeb's hypothesis that 3I/Atlas might be artificial, or that it could be a probe sent by an alien civilization, introduces the exciting possibility that the object could contain evidence of life beyond our planet. The search for extraterrestrial life has been a cornerstone of space exploration for decades, and objects like 3I/Atlas offer a completely new avenue for this search. If 3I/Atlas were an artificial probe, it could be the first direct evidence that we're not alone in the universe. The implications of such a discovery would be far-reaching, not only for astrophysics but also for fields like biology, philosophy, and sociology. Finding evidence of extraterrestrial life would revolutionize our understanding of our place in the cosmos. It could prompt a re-evaluation of many long-held assumptions about life's origins and its potential for existence elsewhere in the universe. The sheer possibility of such a discovery would challenge the very foundations of science, potentially leading to breakthroughs in how we approach life's nature, both on Earth and in other parts of the galaxy. Even if 3I/Atlas is not a probe and is instead a natural object, it still holds the potential to provide valuable insights into the conditions that support life. By studying its composition, scientists could uncover clues about the types of materials and environments that are common across the galaxy. If 3I/Atlas contains water, organic molecules, or other substances necessary for life, it could suggest that the ingredients for life are far more widespread than previously thought. This would significantly increase the likelihood that life might exist elsewhere in the universe and could fuel the search for habitable exoplanets and moons with similar ingredients. The study of interstellar objects like 3I/Atlas represents a new frontier in the search for life. These objects, whether they contain evidence of life themselves or not, could help guide future missions to other star systems. Examining objects from different star systems could provide insights into the conditions that might foster life on distant planets and moons. For example, the study of 3I/Atlas could inform scientists about the types of materials that travel between star systems and whether these materials could be viable for supporting life on other planets. If interstellar objects like 3I/Atlas carry key ingredients for life, it might suggest that life has a greater ability to spread throughout the galaxy than we once imagined. In addition to broadening our understanding of the potential for life beyond Earth, studying interstellar objects could offer a unique perspective on the dynamics of space itself. These objects travel across vast stretches of space, often remaining undetected until they approach our solar system. Their journey through interstellar space could reveal new insights into the forces that shape our galaxy, including the gravitational effects of nearby stars and the dynamics of galactic material. By understanding how interstellar objects like 3I/Atlas interact with the solar system, we could learn more about the broader cosmic environment and how these objects might have travelled from distant parts of the galaxy. Furthermore, the study of 3I/Atlas could help refine our search for extraterrestrial life in other star systems. Whether or not 3I/Atlas contains signs of life, its journey and composition could serve as a model for identifying other objects from distant star systems that might harbour similar materials or conditions. By refining the tools and techniques needed to study these objects, we could improve our ability to detect and investigate other potential signs of life across the galaxy. For example, the data collected from 3I/Atlas could inform future missions to study other interstellar objects, or even to launch spacecraft capable of exploring distant exoplanets and moons. In conclusion, the study of interstellar objects like 3I/Atlas represents an exciting new chapter in the search for extraterrestrial life. Whether these objects contain evidence of life or not, they provide crucial clues that could guide our future exploration of the cosmos. If 3I/Atlas or similar objects are found to carry the ingredients for life, it could radically shift our understanding of life's potential beyond Earth. The possibilities are endless, and the discovery of these objects has already opened up new avenues for research that could change the way we think about life in the universe. Whether as potential hosts for life or as keys to understanding the broader dynamics of space, these interstellar visitors could be central to the next phase of our exploration of the universe. The discovery of 3I/Atlas and other interstellar objects marks a pivotal moment in our understanding of the cosmos, but it also raises fundamental questions about how humanity will respond to these new frontiers. For centuries, space exploration has been largely confined to our own solar system. We've sent probes to distant planets, explored moons and asteroids, and even reached the outer reaches of our solar system with the Voyager missions. Yet, interstellar objects like 3I/Atlas suggest that our exploration of space could extend far beyond the limits of our solar system, pushing the boundaries of human discovery and technological innovation. The idea of sending spacecraft to study objects like 3I/Atlas would require significant advancements in technology, particularly in propulsion systems and spacecraft design. Current propulsion technologies are not capable of reaching interstellar objects with the speed and precision required to study them up close. This gap in capabilities has prompted scientists and engineers to rethink the possibilities of space travel. The future of interstellar exploration could lead to a new era of innovation, where we see the development of faster spacecraft that can travel vast distances. Emerging technologies such as solar sails, nuclear propulsion, and even new propulsion methods that have yet to be conceived could be the key to making this ambition a reality. Solar sails, which harness the power of sunlight to propel spacecraft, represent a promising technology for interstellar exploration. Unlike traditional rockets that rely on fuel, solar sails use the pressure of photons from the sun to propel spacecraft, potentially offering a more efficient and sustainable means of travel over vast distances. Similarly, nuclear propulsion systems, which use nuclear reactions to generate thrust, could significantly shorten the travel time required to reach interstellar objects. These technologies, among others, are currently in development or are being actively researched and could one day enable humanity to send spacecraft to study interstellar objects like 3I/Atlas. Moreover, the study of interstellar objects like 3I/Atlas could ignite a new wave of innovation in spacecraft design. Crafting spacecraft capable of withstanding the harsh conditions of interstellar space, where temperatures drop dramatically, radiation levels fluctuate, and distances are enormous, would require breakthroughs in materials science, energy storage, and life support systems. These advancements would not only support space exploration, but could also have broader applications in fields like medicine, environmental science, and energy production, benefiting life on Earth as well. Interstellar travel and exploration are no longer just concepts confined to science fiction. As we learn more about interstellar objects like 3I/Atlas and the potential for future interstellar visitors, the dream of travelling to other star systems may become a reality sooner than we think. The prospect of visiting distant stars or exploring other habitable planets within our reach offers exciting possibilities for humanity's future. The knowledge we gain from exploring interstellar objects could not only deepen our understanding of the universe, but also help answer one of humanity's oldest questions. Are we alone in the cosmos? Such advancements in space exploration would have profound implications for humanity's future as a spacefaring civilization. The ability to study interstellar objects in more detail could lead to groundbreaking discoveries about the composition of distant star systems, the conditions that support life, and the possibilities for human colonization of other planets. It could also encourage a broader global collaboration in space exploration, bringing together nations, scientists, and engineers to work toward common goals. Just as the Apollo missions to the Moon united people around the goal of reaching new frontiers, interstellar exploration could become a unifying force for future generations. The expansion of space exploration beyond our solar system also raises important questions about the ethical and societal implications of such endeavours. As humanity looks outward, the exploration and eventual colonization of other planets and star systems could lead to challenges in governance, resource allocation, and the preservation of extraterrestrial environments. It will be crucial to ensure that these efforts are conducted responsibly, with a focus on sustainability and respect for the environments we encounter. The future of interstellar exploration will require not only technological innovation, but also careful consideration of the moral and ethical dimensions of our actions. In conclusion, the discovery of interstellar objects like 3I/Atlas signals the beginning of a new era in space exploration. The idea of sending spacecraft to study these objects and eventually travelling to other star systems could transform our scientific knowledge and open up new possibilities for humanity as a spacefaring civilization. Achieving this goal will require major advancements in technology, including propulsion systems and spacecraft design, but the potential rewards are immense. As we move closer to making interstellar exploration a reality, we must remain focused on the challenges and opportunities ahead, as the journey into the stars could shape humanity's future for generations to come. In many ways, 3I/Atlas is just the beginning of a new chapter in our exploration of the cosmos. The discovery of interstellar objects has already forced us to challenge our assumptions about space, our solar system, and our place in the vast universe. Avi Loeb's theory that 3I/Atlas could be captured by the Sun, and his broader ideas about the potential for extraterrestrial technology, have pushed the boundaries of scientific inquiry and opened new doors for exploration. Regardless of whether 3I/Atlas turns out to be artificial, its presence in our solar system marks the start of a new era of discovery. As we continue to study interstellar objects, we are embarking on a journey that could reshape our understanding of the universe. The questions raised by 3I/Atlas about the nature of interstellar travel, the possibility of life beyond Earth, and the role of our solar system in the broader cosmos are only the tip of the iceberg. These initial discoveries are just the beginning of a larger cosmic puzzle that humanity will continue to unravel for generations to come. With each new interstellar object, we are presented with an opportunity to rethink everything we thought we knew about space and our place in it. One of the most profound aspects of studying interstellar objects like 3I/Atlas is the potential to learn more about the broader dynamics of the universe. These objects come from outside our solar system, offering a rare glimpse into the conditions and environments of distant star systems. As we track and study these visitors, we could gain valuable insights into the makeup of other galaxies, the forces that shape their evolution, and even the potential for life beyond Earth. If 3I/Atlas or similar objects contain materials that are conducive to life, such as water, organic molecules, or other essential elements, it could dramatically increase the likelihood that life exists elsewhere in the universe. This would shift the focus of our search for life from distant exoplanets to the very objects that pass through our cosmic neighbourhood. The questions about interstellar travel also play a critical role in how we think about the future of space exploration. The mere presence of objects like 3I/Atlas raises the possibility that our solar system may not be as isolated as we once believed. If interstellar objects are more common than previously thought, we may soon find ourselves in a new era of space exploration where the search for these visitors becomes just as important as the search for habitable planets. With the advancements in telescope technology and future spacecraft design, we may be able to track and study these objects with greater precision and reach. Solar sails, nuclear propulsion, and other emerging technologies could one day allow us to send spacecraft to explore these objects up close, expanding our understanding of the universe and potentially unlocking secrets that could reshape our entire worldview. Moreover, the study of interstellar objects could lead to new insights into the nature of space travel itself. As we learn more about the interactions between objects like 3I/Atlas and our solar system, we could gain a deeper understanding of the forces that govern the movement of matter across the galaxy. This knowledge could have practical applications, from improving our understanding of the origins and dynamics of our own solar system to helping us design better spacecraft for interstellar travel. The technology developed to study and explore interstellar objects could have ripple effects across other scientific fields, leading to advances in engineering, materials science, and physics. As we look ahead, every discovery, every new interstellar visitor offers another piece of this cosmic puzzle. 3I/Atlas, whether it remains in our solar system or continues its journey into the stars, has already altered the way we think about space. Its presence has reminded us that the universe is far stranger, far more complex, and far more interconnected than we ever imagined. With each passing discovery, we're confronted with the humbling realization that the universe is not static, but dynamic and ever-changing. In this new age of exploration, humanity stands at the precipice of uncovering new knowledge that could change everything. The study of interstellar objects like 3I/Atlas is not just an academic pursuit, but a philosophical one. It challenges us to reconsider our place in the universe and the nature of life itself. Whether these objects carry signs of extraterrestrial life or not, they represent a new frontier in human understanding, one that could unlock answers to some of the most profound questions we've ever asked. The journey ahead promises to be as exhilarating as it is uncertain. As we continue to study interstellar visitors and search for answers, we will inevitably discover that the universe is full of surprises, each one leading us further down the path of knowledge. The discoveries sparked by objects like 3I/Atlas will continue to shape the future of space exploration, and in doing so will ensure that our quest for understanding the cosmos is far from over.